Binary basics. The easiest path to understanding zeros and ones. How Base-2 works. By now, you are probably feeling pretty comfortable with Base-10 and how the decimal system uses place value to build numbers. Now we will switch gears and look at how things work in the world of binary, also known as Base-2. If Base-10 is the language of humans, Base-2 is the native language of computers. Don't worry if it sounds a little mysterious at first. The good news is that the core principles you've learned so far for Base-10 work almost the same way in Base-2. The biggest difference. Instead of using 10 digits, binary uses only 2 digits, 0 and 1. To really understand how binary works, it helps to look closely at its place value system. Just like Base-10, the value of each digit in a binary number depends entirely on its position. In decimal, every time you move one spot to the left, the value increases by a multiple of 10. In binary, though, the pattern is simpler. Each new place value to the left is worth 2 times more than the one before it. That's the heart of Base-2. Every step left in binary multiplies the value by 2, not 10. So the digit all the way to the right is still called the ones place because it represents a single unit, just like in decimal. The next spot to the left is the twos place, since it represents 2 units. Keep moving left and you'll get the fours place, then the eights, the 16s, the 32s, the 64s, the 128s, and so on. Each time, the value doubles. This doubling pattern is what gives binary its power, and it's the key reason computers love using it so much. The system is simple, predictable, and perfect for hardware that only needs to check if something is on or off. Counting in binary follows the same rollover pattern you already know from decimal as well. You start at 0, then move up to 1. But since there's no digit for 2, you have to roll over right away. So after 1 comes 10. And yes, that is how it is pronounced in binary. We say 10, not 10. That is because each digit in binary only ever represents 0 or 1 of each place value, not the number itself. This also keeps things clear and avoids confusing binary numbers with their decimal cousins. After 10 comes 11, then 100, and so on. It's like an odometer, but it rolls over much more frequently since you only have 2 digits to use. This frequent rollover is the biggest difference between binary and decimal. In decimal, you go all the way from 0 to 9 before you need a new column. In binary, you get only to 1 before you have to start a new place. Each time you run out of digits, you add another column to the left and the place value doubles. By first understanding binary place value, you open the door to a whole new numbering system. Just like with decimal numbers, each position in a binary number represents a certain value. Only now, every place is a power of 2, instead of a power of 10. As you build bigger binary numbers, you simply keep adding digits to the left. Every time you run out of options with zeros and ones, you will roll over to a new column. Additionally, don't forget to pronounce each binary digit separately. For example, say 10 instead of 10, and you'll keep everything clear. Now that you see how counting and place value work in binary, you should be ready to start reading and writing binary numbers in their standard, expanded, and exponential forms just like you did with decimal numbers. Thank you for watching. Subscribe for more great content.